In this class, we are going to continue with the examples of groups. In the last class, we have seen that Z, Q, R and C are not groups with respect to multiplication. What was the reason? Phi inverse was 1 upon 5, which was not present in Z. Thus, Z was not a group with respect to multiplication. In fact, there is an issue for 0 as well in the Z. But if you move towards rationals, the inverse of 5 do exist, right, instead of rationals. And if you take in fact any other element of rational, still it holds. Only there is one element that is problematic instead of rationals, that is nothing but 0. So the question is, what if we remove 0 and try to check whether set of rationals is again a group with respect to multiplication or not. Now whenever we remove 0 from set of rational numbers, we denote that set by Q star. Similarly, if we remove 0 from R, that will be denoted by R star and C star, right, for set of complex numbers. Now one by one we will verify the properties. Obviously, Q star is a non-empty set. Multiplication is a binary operation set of rational numbers, because if you take two rational numbers, the product of two rational numbers is again going to be a rational number. So I will say, as 1 belongs to Q star, therefore Q star is non-empty. Clearly, multiplication is a binary operation on Q star. Now the first property is associativity. So if you take three rational numbers and if you multiply the first two rational numbers first and do the calculation, now next time you multiply the two rational numbers on the other side and again you simplify, and you will observe that we are getting the same answers. No issue there as well. So directly I will write clearly this A multiplied by B multiplied by C is actually equal to A multiplied by B multiplied by C for all ABC belongs to Q star. I insist you take three rational numbers and verify the property on yourself. Now moving towards the next one, existence of identity. As discussed in the last class, whenever we are having addition, the identity is 0. Whenever we have multiplication, the identity comes out to be 1. So I will say there exists 1 belongs to Q star such that this A multiplied by 1 is A, which is 1 multiplied by A for all A belongs to Q star. Thus, identity also exists. Now what about the inverse? So what I will say here, for each A belongs to Q star, there exists, what is our A inverse? Yes, simply take the reciprocal belonging to Q star such that what A into A inverse is equal to 1, which is equal to A inverse into A, and therefore this Q star with respect to multiplication is a group. Now the obvious question is whether it is a abelian group or not. So if you verify, if you take two rationals, for example, let us take a particular case, 2 upon 3 multiplied by 9 upon 7, and if you try to calculate the answer and if you same do for 9 upon 7 multiplied by 2 upon 3, you will see that we are getting exactly same answer. So this we can generalize. In fact, this holds for any two rational numbers, and therefore set of rational numbers, I mean Q star, with respect to multiplication is a abelian group. So let me write it properly. Also, A multiplied by B is equal to B multiplied by A for all AB belongs to Q star, and therefore it is a group with respect to multiplication. Only one thing to note, here I have said dot, and everywhere I have used the cross to denote the multiplication, so that it is visible in the video, but we can simply use dot everywhere, right? This A dot 1, A dot A inverse, this can be done. Now can the same thing be done for R star? Obviously yes. The proof is exactly parallel, no changes here. Now the question is, can it be done for C star as well? That I leave it to you.